Hi there, and welcome to Ovalhead's Den of Electronic Iniquity, brought to you by, nobody. So, anyways, I've been thinking for a long time about using an ultrasound sensor, like a ranging sensor, to build basically what amounts to a MIDI theremin, or a theremin. Something you can control like notes, or filter frequencies, or any number of things depending on like what I decide I want it to do. Now, eventually it'll be some box, but instead of having two antennas coming out of it, like a theremin usually does, it'll just have these two little eyeballs, which is sort of like that guy from Short Circuit. But anyways, one of these guys sends a signal, it sends an ultrasound signal, and that bounces off of something, and the other one detects it coming back. This is very similar to the Polaroid lane cameras back in the, I don't know, the 70s or 80s. It was the autofocus method that they used, as opposed to infrared and lasers, which we all use now, which is a lot more efficient because light travels faster than sound, unless you're moving through a denser medium. Anyways, that's beside the point. So what we have here, we have my Raspberry Pi 3B plus connected to a breadboard here with the GPIO header. And right there we've got our buzzer. Right there we've got our ultrasound emitter and receiver. And what we've done is right now the ultrasound is connected to the power rails over here, right? And so is the buzzer. That's a 5-volt power rail and ground. The ultrasound sensor is also connected to the clock on this side, on the right-hand side. That's important because timing is important when you're doing something like ranging. Like, think of this as sonar. It's very similar to what submarines do. So basically what they're doing is they're pinging a signal out and they're getting something back, and they measure that distance to understand exactly where that thing is. That's exactly how this thing works. However, it's ultrasound, so you can't hear it. Now, so it has a clock and a signal. The signal is to ping out, the clock is to wait and to get it back and understand the distance between like when it sent the signal and when it received the signal. Now, this guy over here, the buzzer, he's way less important, way less complicated. All he has is a signal and a 5-volt power and ground combination. No big deal. I have no idea why they have like this crazy amount of LEDs on him, like it's like freaking disco over here, and he sounds terrible. Anyways, so let's do this. Just for grins, let's just play what it sounds like if we just do the buzzer. Let me play a little song through it so you'll understand like the capabilities of this grand musical instrument. All right, ready? So it's like one of those greeting cards, basically, except it's not polyphonic. It's like one of those ones you got in like 1985, and you're like, holy cow, I opened this card and it played music to me. Yeah, that's pretty much it. So yeah, we're gonna kill that. But this is just a test that this actually works, and the code that actually runs, the test code that runs the passive buzzer actually does something, so that's important. You know, you sort of want to part your things out into components before you put everything together. That goes with programming, it goes with like developing electronics or anything, just to make sure things work in isolation. Really wish I could get these guys to work. This little display here, they could put notes on there and say fun things. This guy here is actually a touchscreen, but I can't really put a hat on there because, you know, the header is taken up by that ribbon cable. That sucks. Anyways, enough of this catastrophe in PC. Anyways, all right, so that's that. We know the buzzer works. We know that for a fact, so that's cool. So now what we're gonna do is we're gonna send signals to the buzzer based on the distance right here. And what I did is I took the amount of centimeters, right, that an object was away from this guy, and I multiplied that times 10, because, you know, the outside frequency you're going to get is probably like in the 900 range, Anything else is going to be sort of like suspect. So let's try this out. So now what we're going to do is not passive buzzer, ultrasound ranging. So yeah, this was actually the lab script, and I just completely rewrote it for this actual purpose. By the way, using shell within VS Code to write Python on your Raspberry Pi is actually pretty easy and pretty cool. All right, so let's go. Bang! All right, what you're hearing right now, that cacophony of holy crap, is basically a constant distance. So if we're looking at this guy right here, this is telling us the centimeters, right? Yeah, it's not perfect, right? It's not a perfect number. It's gonna float around because it's, you know, sound is not like light. It's not a laser that's beaming at something. It's something that's going on in a cone. And it's also dependent on air density and all sorts of crazy stuff, the medium it moves through. And did you know the speed of sound is faster through water than it is through air? Anyways, watch this. So now, closer, further away. Right? So even though this sounds like absolute garbage, you can see the potential. I hope you can, because I can too. This could be filter resonance. This could be filter cutoff. This could be pitch bend. This could be scratching a record through thin air. Wow, think about that. That's crazy sound. So all I need for that is to send a MIDI signal, which means I need access to the UART and the clock and a number of other things. So we'll cross that bridge when we come to it. But we have other things here that we could probably play around with. I don't, you know, got a remote control on a, you know, IR thing. Well, this is way too much. Anyways, so yeah. So next steps, a couple more sensors, right? Maybe find myself a Nintendo Power Glove, because that has flexor sensors and accelerometers built into it. What is that going to look like? We're talking every parameter in MIDI editable. Have a config file, have the one button start, boom, there you go. You have a Raspberry Pi in a box, ready to go, controller done. Anything can be done. Any parameter in Reason, Reaper, whatever you want to know. Like automation, you know, the freaking machine here. Good times. Anyways, have a good night, and I'll talk to you later. Comment, maybe, unlike, or like. Anyways, yeah, it's the breadboard configuration if you're interested. A little fuzzy, but there she is. Adios, mein Freund.